All right, let's jump right into this explainer and tackle what is honestly one of the most massive challenges in modern software development right now. We're talking about using AI assistants for real-world enterprise-scale code bases. Look, we all know AI coding assistants are fundamentally changing how we write software. Out of the box, they are incredibly impressive. But there is a huge, often completely unspoken gap between what these models can do in a neat, controlled 5-minute demo and what actually happens when you unleash them on a sprawling, legacy, real-world system. So today, we're unpacking some truly groundbreaking research from Salesforce AI. They've been testing the absolute breaking point of these models to see exactly what happens when the training wheels finally come off.
Picture this, because it's the ultimate developer nightmare scenario. It's Friday afternoon, and you're asking your AI to fix a deeply buried authentication issue that's just hidden somewhere within a sprawling microservices architecture. You absolutely know the pain I'm talking about here. You change one tiny variable in an auth module, and suddenly the payment gateway starts throwing a cryptic error on the complete opposite side of the system. We're talking about 500,000 lines of code spread across 80 different files. Now, most AI benchmarks out there, they only test models on tiny, isolated tasks, like writing a single sorting function or fixing a missing bracket in one file. But as we all know, real software engineering operates at a massively different and much more punishing scale.
And this really highlights the critical difference between an AI that is merely a toy and one that's genuinely an enterprise-grade tool. Because if your AI assistant can only handle a few thousand lines of code before completely losing its train of thought, well, it's essentially just a parlor trick for enterprise developers. Sure, it might save you 5 minutes of typing out boilerplate, but it is not going to solve your actual architectural problems. A true tool needs to deeply understand context, maintain strict consistency, and actively reason across intricate dependencies that are hidden within a million-line architecture. The bottom line from the researchers is crystal clear on this. If your AI assistant cannot scale with the complexity of your codebase, it firmly remains a toy. So here's our roadmap for breaking this down. We'll start with the scaling challenge itself, then introduce the LoCoBench-Agent benchmark, dive into the key insights discovered at scale, and wrap it all up with a practical enterprise action plan. Starting with part 1, the AI scaling challenge, and the journey from simple scripts to full-blown enterprise systems. Let's physically walk through the journey of a codebase as it scales up. At 10,000 tokens, which translates to roughly 3,000 lines of code, you're looking at a small Python service. Honestly, this is the absolute comfort zone for almost every coding assistant on the market right now. Working at this level is just like reading a short story. The AI can easily remember the beginning when it reaches the end. The entire context sits comfortably right there in its active memory. It doesn't need any clever engineering or complex retrieval tricks to understand exactly what is going on.
But then we hit 100,000 tokens, mapping to a medium web application of about 30,000 lines. And this is the exact moment where the cracks really begin to show. At this scale, the AI can no longer hold everything in perfect focus simultaneously. Finding the right code from across various directories requires the AI to start making active, strategic choices about what to pay attention to, and maybe more importantly, what to ignore. If it makes the wrong assumption here, it's going to hallucinate a fix based on totally incomplete information.
Now jump to 500,000 tokens. We are now looking at a 150,000-line complex microservices system. Think about your own systems of that size. This severely tests the AI's ability to maintain context. It is no longer just about reading code line by line. It's about understanding architectural patterns that span dozens of interacting services. The AI has to inherently understand that changing a database schema over in Service A is going to cascade and break the API payload in Service D. The cognitive load for the model at this tier is just immense.
And finally, at 1 million tokens, a 300,000-line enterprise system, current models struggle immensely. To put that computational weight into perspective, that is a 100 times increase in scale from our first stop. At this level, an AI assistant basically goes from being a highly helpful colleague to acting like a deeply confused intern. It has a remarkably hard time surfacing relevant code, focusing on critical overarching patterns, and staying consistent across long-running conversations. The sheer volume of information simply drowns out the relevant signals.
Moving to part 2, let's introduce LoCoBench-Agent and how we actually go about testing AI at this massive enterprise scale. To test these exact limitations, Salesforce AI Research had to build a completely new definitive benchmark, because up until now, we completely lacked a standardized test at this extreme scale. LoCoBench-Agent tests 8,000 complex, realistic software engineering scenarios.
And we're not talking about a simple Python script test here. It covers 10 different programming languages, including JavaScript, Java, and C++. It specifically evaluates the grueling tasks that senior developers actually do every single day, debugging complex multi-file issues, refactoring massive interwoven architectures, and conducting deep security audits. Tasks that require a flawless understanding of context spread out across the entirety of a massive codebase. To pinpoint exactly where an AI breaks down, this benchmark systematically scales across 4 distinct difficulty levels. It categorizes the environment starting from easy, small services under 50K tokens, moving up through medium and hard, and goes all the way to expert, enterprise codebases pushing 1 million tokens. This graduated, highly controlled approach is brilliant because it allows researchers to identify the exact token threshold where an AI stops actually understanding the architecture and just starts guessing. And because real coding is never just a simple interaction where you ask one question and get one perfect answer, the benchmark tests continuous conversations up to 50 turns. Think about your actual workflow. You explore the codebase, analyze dependencies, attempt to fix, encounter an error, and then validate again. That takes dozens of complex prompts. LoCoBench-Agent checks if the AI can actually remember the critical context established way back in turn 3 when you were deep into the weeds all the way on turn 45. Which brings us to part 3, the key insights at scale, and what this benchmark actually revealed. Putting AI models through this rigorous enterprise-scale gauntlet revealed 3 crucial insights. The first one is a fundamental trade-off. Your AI can either deeply understand the massive codebase by taking its sweet time, or it can be incredibly fast and run a really high risk of missing critical context. It's exactly like choosing between a meticulous researcher who takes a full week to read every single book in the library versus an assistant who just skims the back cover summaries but might completely miss a critical footnote. If you want thorough understanding, the AI has to perform extensive exploration, reading many files and tracing dependencies slowly. And right now, no current AI architecture resolves this tension perfectly. The second crucial point is this, and it's a big one. A massive 1 million token context window is virtually meaningless if the AI lacks sophisticated memory management. Vendors absolutely love to aggressively advertise massive context windows as their ultimate selling point. It sounds amazing on paper, but the research shows that some models with only 128K context window actually dramatically outperform the 1M window models. Why? Because having a giant warehouse to store information is completely useless if you don't have a brilliant inventory system to actually find what you need. Intelligent memory management, how the AI organizes, compresses, and retrieves information, matters so much more than just raw storage capacity. Furthermore, the most effective AIs deploy strategic exploration using semantic search. Let's break that down a bit. Semantic search means the AI understands the actual intent and conceptual meaning of the code to find relevant modules rather than just attempting a literal, impossible keyword hunt through every single file. When your codebase exceeds 100K tokens, trying to brute force read everything upfront is a guaranteed failing strategy. The absolute best models act like detectives. They use semantic search to identify the relevant modules first, achieving comparable understanding, but with a 5 to 6% boost in efficiency. And at the scale of 1 million lines of code, that 5% efficiency gain is absolutely critical to keeping the system from just timing out completely. Finally, part 4, the enterprise action plan and what all of this actually means for your business. Look, knowing these deep technical limitations is only half the battle. The real tangible value here is how you adapt your AI strategy. So, follow this clear playbook when adopting AI for your engineering teams. Number 1, evaluate tools at your actual codebase scale. Please do not rely on vendors' small-scale benchmarks. 2, explicitly prioritize tools with strong memory architecture over those just boasting massive raw token counts. 3, aggressively track AI efficiency. If a tool takes way too many conversation turns to find a bug, it is wasting expensive developer time. 4, plan your workflows around the hard truth that current AIs struggle with multi-session development on massive codebases. And 5, demand tools that utilize strategic exploration and semantic search, rather than basic brute force reading. The research leaves us with a powerful, undeniable conclusion. When it comes to real-world software engineering, scale fundamentally matters. We are rapidly moving into an era where AI coding assistants are no longer just optional extras. They're becoming critical enterprise infrastructure. Evaluating these massive foundational models on how well they can write a single isolated Python script is exactly like test driving a Formula One car in a crowded grocery store parking lot. It just doesn't make any logical sense, and it won't tell you a thing about how it actually performs on the track.
scale completely changes the nature of the task. So, as your code base inevitably continues to grow, you have to ask yourself a hard question. Is your AI assistant truly a tool built to handle the future, or is it just a toy holding you back? The future of software engineering requires models that don't just read text, but deeply understand, map, and navigate intricate enterprise architectures. Are the tools you're investing heavily in today actually capable of keeping up with the million-line code bases you'll be building tomorrow? Because that is the question you need to be asking right now.